Hi, today we're going to look at the idea that if we're given any 2 points in a Cartesian plane, that is, when you've got like a y-axis and an x-axis, and it might include negatives as well, then how can we find the equation of the line that goes through it? And what we know is that for this straight line, y is equal to mx plus c. So if we can work out m, which is the gradients, and we can work out the value for c, then we can get the equation of this line. So I've said that. What I want you to do now is pause the video and have a go at these two questions, because this video assumes you've done practice on equation of a parallel lines. Like if you're told a line is parallel to another line and you're given the equation of that original line and you're told a point that it goes through, then you can also work out the equation of the line. This is just taking it one step further. So for this first question, calculate the gradient between these points. There are two methods really. The first method is actually to use something that I've talked about before, the fact that m is y2 minus y1 over x2 minus x1. And honestly, this is a formula that is worth knowing, because you don't have to worry about diagrams or anything. You basically are just finding the differences, but it's not the difference because you need to be consistent in how you subtract it. So I'll call the second coordinate, the larger values. This is going to be x2 and y2, and I'll call these ones x1 and y1. And then I'm ready to just substitute it in. Basically, it's going to be 5 minus 3 divided by 6 minus 2, which gives me 2 over 4, which becomes a half. Brilliant. Note, if we do it the other way around, because there's nothing special about this coordinate being x1 and y1, I could do it the other way around, and I could call this x2, y2, and x1, y1, and I could do the same thing. I'd get 3 minus 5 divided by 2 minus 6, which is minus 2 divided by minus 4, which again cancels down to a half. So you can decide how you do this. Just be consistent. Basically, you're just finding that you're just doing one minus the other one divided by that minus that. The more practice you get, the quicker you can do this. Just one other way. If you don't like that formula, then you can actually, and I do recommend this sometimes, draw a little sketch, put the coordinates in. So this one is 2, 3. And put this one in. Like, you have to put it in the right kind of place now, really, to make sure you don't make a mistake. And then we're interested in this gradient, and then just figure out how many are going along. I'm going along 4. I'm going up 2. Okay, I've just done y2 minus y1 and x2 minus x1 without kind of really thinking about it. And again, I would get a gradient of a half. Now, given that information, can you have a go at calculating the equation of the straight line that passes through these 2 points? Okay, basically, like we've just done an extra step to what we did when we did parallel lines, but now we can write down that y is equal to a half x plus c. So that is half of the question sorted. Gradient is equal to a half. So obviously, if you weren't told hence calculate, if this was the question from the start, you'd have to first of all do this step. But I've got it now. And now it's back to substituting in to work out the value for c. Which one do we use? We can use either one, and that's the great thing about this. We can just use either one. We don't need to use both. It's just slightly more information than we need. But essentially, we have the gradient. We've got that point there and that point there. So with either one, you can work back to what c would equal. Okay, I'll use the first one. It's slightly smaller. So, or maybe I should just write as I did before. When x equals 2, y equals 3. So I can write down that 3 is equal to a half times 2. that's just 1 plus c. You can put that extra step in if you like, 1/2 times 2. I've just gone straight to it. And then c is going to equal 2. So finally, I've got y is equal to 1/2 x plus 2. And that is my answer. I found the equation of the straight line given 2 points. If we'd used 6 and 5, let's just say that if we could do that, then I would have got when x is equal to 6, y is equal to 5. And I could have substituted that in. So then it would have been 5 is equal to 1/2 of 6, which is 3, plus c, and I would have again got c equal to 2. So you can use that to check, or you could, when you get your final answer, you could substitute x equals 6 in, and then you'd see that y is equal to 5. So you can double check basically using your second point. But just to summarize, when you're given a question like this, like from the start, without this like little bit of scaffolding I gave you, you first of all find the gradient using one of the 3 approaches I've talked about here. Then you substitute one of the points in to work out the value for c, and good practice is just to check that it works. I've got a little like handout of the whole process here as well. They've drawn the triangle, but they've basically done exactly the same thing. I just thought I'd put that up as well. If you didn't quite follow my work, and you can look through this. I want you to try a couple more now from scratch. So we've got A, B, C as coordinates. Can you find the equation of the straight line joining A to B? Can you do it to B to C? And what can you say about points A, B, and C? Pause the video, have a go. I'm going to reveal the answer in a minute, and then I'm also going to go through this question. So here goes. Those are the answers. So if you got that, then you can move on, to be honest. Otherwise, I'm going to talk about it. I'll talk about what collinear is at the end. So, right, AB, that's the first thing to sort out. The line AB. Well, I can use the fact that I can do the gradient, and then I can just now look, I'm going to choose this one as x2 and y2. So it's going to be 1 minus minus 1. Just got to be careful here because I've got a double negative. And then I'm divided by minus 4 minus minus 8. Maybe I should have done it the other way around, but it's okay. I'll get away with it. It's going to be 2 over, and then minus 4 minus minus 8 is minus 4 plus 8. So it's 2 over 4, which is 1/2. So then I can write down that y is equal to 1/2 x plus c. And substitute one of the points in. I'm going to pick this one, I think, when x equals minus 4, y is equal to 1. It's got the least number of negatives in it. That's why I've done that. So I can write down that 1 is equal to 1/2 times minus 4. That's minus 2. And therefore c is equal to 3. And I get my first answer. Y is equal to 1/2 x plus 3. Brilliant. Let's do it. That was part A. Let's do part B. It's the same process. So if you were stuck and now you've watched my explanation for A, okay, try and do B yourself. So this is BC. I'm going to go straight to the y2 minus y1 thing again. I'll choose this one as x2, y2, so it's going to be 9. Maybe I should have been more careful and labeled these. I've kind of done this a bit quicker. So I'm doing 9 minus 1 divided by 12 minus minus 4. And that's going to be 8 over 16, which again gives me 1/2. So y is again equal to 1/2 x plus c. When I think I'll avoid the negatives, it's a good shout to just do that. When x equals 12, y equals 9. So, whoops, I'm now substituting for y. It's going to be that 9 is equal to 6 plus c, and again c is equal to 3, and I get the same line. Why did I do that? You don't normally get that sort of thing. It's for part C, basically. It's to get you to think carefully about what is going on. Because basically we've got 3 points, and they all lie along the same straight line. They have the same C. If the C was different, then they would actually be parallel. No, could that happen? I don't think you could get, because you got 2 and then the third one. I don't think you could get, I think you'd have to get them the same. I'm not sure, but in any case, they are along the same line, and that is given the special name collinear. Okay, if you've understood this, then you are in good shape. Just do some more practice and it will come together. This is, for me, this is like a challenging aspect of y equals mx plus c, because you have to be like quite confident with knowing that formula, knowing that m is the gradient, c is the intercept. You've got to be able to calculate the gradient given 2 points, and then you've got to know about this substituting thing. This is generally where people find it the toughest. So it's about practicing and making sure you understand it. But yeah, well done. Keep going. So practice your skills of equations of lines given 2 coordinates. Further, try this exercise. It's a self-checking exercise. So if you do question 1 and you get the answer as, I don't know, EY, that y equals 4x plus 7, then in the box you would write E and Y. I don't think that is actually the answer, but that's just to illustrate it. And then after you've done it, or as you're doing it, you can kind of tell that you're doing it correctly. So it's a really good task, I think. I'm gonna show you the answer, just so you can see, and this is what you get. Really, really terrible joke, but it's, yeah, why not? Okay, and then the challenge questions are as follows, and I'm gonna show the answers and then go through them. So this makes you really think geometrically about what's going on. I'm not going to go through the whole thing. I'm just going to start you off. And I think a really good idea for this is to draw a sketch. So I've got A at 0, 3. It's on the y-axis. B is 6, 6. And then C is 7, 3. So it's slightly further along, but it's actually in line with A. So it's going to be down there. And then it says that AB and BC are 2 sides. So that's really important. I can draw them on, AB and BC. Because there's lots of different places you could draw this parallelogram. I was thinking that I could draw it like maybe over here somewhere, but that wouldn't make BC the side. So now I've got to try and figure out what's going on. And I need these parallel sides, don't I? So I'm making it look like it's a rectangle as well. I kind of regret that. So I'm just going to move this slightly, because it could be a rectangle in theory. Right there, that's a bit better. Okay, because then I know if it's got parallel sides, we can have another side there, and that's going to be where D is. That's the only possible thing that it could be. And then I can figure out the coordinates of D. This is going to be a little bit tricky, but let's work out, how do I go from B to C? Well, I go along 1 and I go down 3. So to get from A to D, I'm going to go along 1 and I'm going to go down 3. And actually, this should have been exactly on that point. It's okay, it's just a sketch to help me figure it out. Now I've got this coordinate, I've done my main things. So I'm told about AB, I'm told about BC. I need to find the equation of the line DC and AC. And because I've got the coordinates, if I just add them on, 7 and 3 and 0 and 3, then I've got enough information now. I'm now doing what I did before. Okay, I'm not going to go through it any more than that, but I've started you off anyway if you were stuck on that extension. And the very last question, it's always good in maths, like to take it to the very limit and generalize. So given a pair of 2 coordinates, any 2 coordinates, how can you find the equation of the straight line that goes through these 2 coordinates? Let's give it a go. Well, first of all, we can write down that m is y2 minus y1 over x2 minus x1. I've talked about this enough. You can draw a triangle to get it if you like. You could have it the other way around as well, y1 minus y2 over x1 minus x2. That would be okay. I'm going to stick with the more kind of traditional format. And now I know that y is mx plus c, so I can write down that y is y2 minus y1. I'm just substituting in for my value for m. And then I times by x plus C. Whew. And I'm not done because now I need to actually work out what C is. That's the only thing I'm missing because Y and X are changing. They're going to be in my final equation, but C I can work out the value of. So what can I do? I can substitute one of the points in, and it doesn't actually matter which one. So let's do when X is equal to X1, Y is equal to Y1. Okay, I'm just picking the first one. Okay, let's give this a go. It's going to be that Y1 is equal to Y2 minus Y1 over X2 minus X1 multiplied through by X1 plus C. And I basically now worked out C. It's it's in terms of all of this, but that is the answer. It's going to be Y1 minus Y2 minus Y1 over X2 minus X1 all multiplied by X. I don't know if you expected a really nice answer, but sorry, that should have been X1 there. But that is it. You could now just basically write this down again, but with C replaced by this, but actually can do one extra thing. We could simplify this, and you can do that by trying to add the fractions. I can write this as Y1 X2 minus X1 all over X2 minus X1. I've basically written it over a common denominator, in the same way that, like, if you have, it's the same way as when you're adding fractions, like 3 over 4 plus like a half. You put it over a common denominator. This is doing it but algebraically. So then I need to still minus, but then I'm going to bring the X1 up into my fraction. I can do this. You're allowed to do that. Y2 minus Y1 over X2 minus X1. And then we can add these fractions. So I'm not gonna say this is an easy question. This is algebraic fractions and generalizing. Lots of difficult mathematical topics at GCSE, but it is coming together. And then finally, what can I do? Can I do anything else with that? No, I think that's as simplified as it gets, to be honest. I can't factorize anything else. Or can I? Aha, maybe I can. I'm gonna multiply it. Multiply it all out. Y1 x2 minus Y1 x1 minus x1 y2 plus x1 y1. Oh, I didn't see that come in. But it makes sense. These two are going to cancel out. And then I'm going to be left with y1 x2 minus x1 y2. And finally, I can write that in. So y equals y2 minus y1 over x2 minus x1. That is my that's my gradient, plus, and then my intercept, as simplified as it can get, is this thing here. And this is the general formula, the equation of a straight line if you're given 2 points.